Okay, this is a numerical on indicated power. It says that a two-stroke IC engine has a mean effective pressure 6 bar and speed of the engine is 1000 rpm. This is rpm. If the bore and stroke are 110 mm and 140 mm, find the IP. That means the indicated pressure. Indicated power. Indicated power. So first, the given values are mean effective pressure, that is 6 bar, engine speed n equals to 1000 rpm, bore and stroke, bore means d equals to 110 mm, that means 0.11 meter, stroke length L 140 mm, that means 0.14 meter. Okay, so the indicated power expression is IP equals to L A N K into 10 by 6 into N. This N defines the number of cylinder. This N defines the number of cylinder. Here the number of cylinder is not given in this question, so we can assume N equals to 1. The value of K, here in this equation the engine is two-stroke engine, so the value of K is 1. Okay, A is the area, so now substituting all these values. Okay, one thing, in this expression the value of P, don't convert the expression of pressure into Newton, into Pascal or Newton per meter square, because already in this expression the bar is converted into Pascal. In this expression already we have converted it. Okay, so you don't need to convert that pressure bar into Pascal. So now just substituting all these values, 6 into 0.14 into pi by 4 d square, this is the area, piston area. Okay, pi by 4 d square, piston area. Speed is 1000 into 1, that is K, into 10 into 1 by 6. Okay, the value becomes 13.3 kilowatt. This is the indicated power value. The second numerical says that a four-cylinder, four-stroke SI engine. SI engine means the petrol engine, develops 14.7 kilowatt at 1000 rpm. The mean effective pressure is 5.5 bar. If the stroke is 1.5 times of the bore, find the bore and stroke. So first, 14.7 kilowatt at 1000 rpm, that means the brake power, the engine develops the brake power at 1000 rpm, and the cylinder is the four cylinder, so n equals to, here n equals to 4, brake power BP equals to 14.7 kilowatt, n equals to n equals to 1000 rpm. Mean effective pressure, here Mean effective pressure means the brake mean effective pressure, PBM, brake mean effective pressure 5.5 bar. The stroke is not given here. Okay. It's a fourth stroke. So K equals to half, and the stroke is 1.5 times. The stroke is 1.5 times of the bore. That means L equals to 1.5 D. Okay, so now the formula, we already know that brake power equals to brake mean effective pressure into L A N K into 10 by 6 into small n kilowatt. Okay, this is the same expression as we have already seen in case of indicated power. Okay, this is the same expression that we have already seen in indicated power. So now substituting all these values, so brake power is 14.7 kilowatt. This is also in terms of kilowatt, so don't need to convert these things into watt. Brake mean effective pressure, that is 5.5. L equals to 1.5 T. Area is pi by 4 into D square. Capital N is 1000. The value of K is obviously half for fourth stroke, into 10 into number of cylinder is 4 divided by 60. Okay, so from this relation we can find D, and the value of D becomes 0.0879 mm, or we can say 87.9 meter. Okay, 87.9 meter. So the L value, that means the stroke length, is equals to 1.5 into 0.0879. that means the value of stroke length becomes, sorry, the unit is wrong. So the value of L becomes 0.1318 meter. So that means 131.8 millimeter. This is the stroke length. Third numerical is the single cylinder 4-stroke SI engine is fitted with a rope brake. The dia of the brake wheel is 600 mm and the rope dia is 26 mm. The dead load on the brake is 200 Newton and the spring balance reading is 30 Newton. Find the engine runs at if the engine runs at 450 rpm, find the brake power. So the dia of the brake wheel is 600 mm, that means 0.6. Rope dia is 26 mm, 0.026 meter. Dead load, that is W 200 mm Newton. Spring balance load is spring balance reading is 30 Newton, and RPM is 450 RPM. Okay, so from the rope brake dynamometer experiment, we have already find out the brake power is, the expression for the brake power is capital W minus S, dead load minus the spring balance load, into pi into the summation of these two dia into the RPM divided by 60,000. Okay, now substituting all these values, 200 minus 30 pi 0.6 plus 0.026 into 450 by 60,000. So the value of big power becomes 2.5 kilowatt. By calculating the values, we get the brake power is 2.5 kilowatt. So fourth numerical is, the following observation were recorded during a test on a single cylinder SI engine. Bore is 300 mm, stroke 450 mm, speed of the engine is 300 rpm. IMEP, that is indicated mean effective pressure, IMEP 6 bar. Net brake load is 1.6 kilonewton. Brake drum dia is 1.8 meter and rope dia is 2 centimeter. So we have to find out the indicated power, brake power and the mechanical efficiency. Okay, so let's start. The diameter is that means the bore dia is given as 300 mm, so that means 0.3 meter. Stroke length is 450 mm, that is 0.45. RPM, engine speed is 300 rpm. Mean effective pressure, indicated mean effective pressure 6 bar. Net load, that is on brake, net brake load W minus S is 1.5 kilonewton. Brake wheel dia is 1.8, that is D suffix D, and the small d is the rope dia, that is 2 centimeter, 0.02. Okay, so to find out the indicated power, number 1, indicated power. So the the formula is indicated mean effective pressure LANK into small n into 10 by 6. So indicated mean effective pressure is 6, L is 0.45, A is pi by 4, d square, d means 0.3, 0.3 square, capital N is 300, K value is half because it's a 4-stroke engine. Number of cylinder is not given here, so we assume that is 1 into 10 by 6. Number of cylinder is given in the question. Number of cylinder is given, that is single cylinder, so that's why it's 1 and into 10 by 6. Number of cylinder is given. So the indicated power, the value of the indicated power becomes 47.71 kilowatt. Okay, next is the brake power. The brake power expression is W minus S into pi into dt plus small d into n by 60. Okay, so in terms of kilowatt. Okay, so W minus S is 1.5 into pi into 1.8 plus 0.02. Okay, RPM is 300 by 60. So the value of brake power becomes 42.88 kilowatt. Okay, so the last one is find out the mechanical efficiency. So expression for the mechanical efficiency is it's a ratio of brake power to indicated power. So brake power is 42.88 by indicated power is 47.71. Okay, so the value becomes 0.8987, that is equals to 89.87%. Thank you. Okay, so our next numerical says that a 4-cylinder 4-stroke square SI engine. Okay, so square engine means the board and stroke, these two lengths are same in case of square engine, has a compression ratio 8 and bore of 100 mm. The volumetric efficiency of each cylinder is 75%. The engine speed is 4800 rpm with an air fuel ratio 15. Obviously it is 15:1 actually. Given that calorific value, this is CV, means calorific value 42 megajoule per kg, atmospheric density, that means atmospheric air density is 1.12 kg per meter cube, mean effective pressure 10 bar, and mechanical efficiency 80%. Find the indicated thermal efficiency, brake power, and brake specific fuel consumption. This is brake specific fuel consumption, BSFC. So let's start. The number of cylinder small n is 4. Okay, it's a 4-stroke engine, so K value is half. Compression ratio, that is small r, is 8. Bore dia, that is 100 mm. Obviously it is equals to stroke, or we can say 0.1 meter. Volumetric efficiency is 75%. Speed of the engine RPM. Air fuel ratio that is 15:1 or 15. Calorific value 42 megajoule per kg. Density of air mean effective pressure and mechanical efficiency. So these are the given value. Okay, so first find out the indicated power, that is number 1 IP. We know the formula. The formula is LAMK into small n into 10/6. So P value is 10. L is 0.1. Area is pi/4 into 0.1 square into RPM. The value of RPM is 4800. K value is half. Small n is 4 into 10 into 10/6. So that becomes 125.66 kilowatt. This is the value of indicated power. So to find out the brake power, let's start. To find out the brake power, let's first find out the air consumption. Air consumption. Air consumption is equals to number of cylinder into pi/4 d square into L, that is the stroke volume, into engine speed into K, that means n/2, into the number of cylinder into the stroke volume into n into K. K means 1/2, half, into volumetric efficiency. Okay, I'm not K is not written here. Okay, so now substituting the values, that is 4 into pi/4 into 0.1 square into 0.1 into 4800/2 into the volumetric efficiency. The value of the volumetric efficiency is 75, so 0.75. So air consumption, the value of air consumption becomes 5.655 meter cube per minute, or we can say that is 0.09425 meter cube per second. This is the value of air consumption. Okay, so let's find out the mass flow rate of air. Mass flow rate of air. Mass flow rate of air means the air consumption into the density. So that is 0.09425 into the value of density is 1.12. So that gives us 0.1056 kg per second. This is the mass flow rate of air, or simply you can m dot a. Okay, so now the fuel consumption. Fuel consumption is equals to mass flow rate of air by the air fuel ratio. Mass flow rate of, so the fuel consumption is mass flow rate of air by air fuel ratio. That means air fuel ratio is 15. So that becomes this is the fuel consumption. Okay, so from this relation we can easily find out the indicated thermal efficiency, then we will find out the brake power. Okay, so the formula for indicated thermal efficiency is eta th I or ith, that is indicated power by mass flow rate of fuel into the calorific value. Indicated power, this is the expression for indicated thermal efficiency, so that is equals to indicated power is equals to mass flow rate of fuel by calorific value. So the value of indicated power is 125.66 into 10 to the power 3. Mass flow rate of fuel is 0.00704. Okay, so calorific value is 42 megajoule, that means 42 into 10 to the power 6. So indicated thermal efficiency is 0.425 or 42.5%. This is the value of indicated thermal efficiency. Now the third one, now the brake power. Okay, brake power. So the brake power formula is indicated power into the mechanical efficiency, indicated power into mechanical efficiency. So the indicated power value is 125.66 kilowatt into mechanical efficiency is 80%, so 0.8. So that becomes 100.53 kilowatt. This is the value of brake power. So next question is find the brake specific fuel consumption. So brake specific fuel consumption, that is BSFC. So the value of BSFC is the fuel consumption by the divided by the brake power. The fuel consumption divided by the brake power. This is a brake specific fuel consumption. Okay, but the unit is we have to convert this unit in terms of kg per kilowatt hour. So to convert it into to convert this mass flow rate of fuel into kg per hour, we have to multiply 0.00701 into 3600 divided by the brake power 1053. Okay, and the unit is kg per kilowatt hour, kg per kilowatt hour. Okay, so the value becomes 0.252 kg per kilowatt hour. Hi students, in this numerical it says that in a test on a single cylinder 4-stroke gas engine with explosion is every cycle, the gas consumption given by the meter was 0.216 meter cube per minute. The pressure and temperature of the gas being 75 mm of water and 17 degrees Celsius. The air consumption was 2.84 kg per minute. The temperature being 17 degrees Celsius and barometer reading 745 mm of Hg. The bore and stroke are 250 mm and 475 mm, and RPM is 240. We have to find out the volumetric efficiency of the engine referred to volume of charge at NTP. Assume R for air as 287 joule per kg Kelvin. So let's start. First one is gas consumption. Gas so the given data are gas consumption, that is V1 equals to 0.216 meter cube per minute. Pressure of gas is 75 mm of water. Temperature of gas is T1, that is 290 Kelvin. Air consumption is 2.84 kg per minute. Temperature of air is again 290 Kelvin. Barometer reading is 745 mm of Hg. Bore that is piston dia 250 mm, that is 0.25 meter. Stroke length is 475 mm, 0.475 meter. Engine speed is 240 rpm, and finally the R, that is gas constant, for air is 287 joule per kg Kelvin. Okay, so the pressure of gas first. That is, in the question the pressure of gas is given 75 mm of water. Let's convert it into Hg, that is 75 divided by 13.6 plus the barometric reading. The barometric reading is 745 mm of Hg, so plus 745, so that gives 750.5 mm of Hg. This is the total gas pressure. Okay, at NTP the pressure and temperature are this is P1. Okay, so at NTP the pressure is, we all know that, that is 760 mm of Hg, and temperature is 273 Kelvin. So we have to find out the volume, that is V2. Okay, first we have to find out the volume. So you know the formula, that is P1 V1 by T1 is equals to P2 V2 by T2. So P1 value is, this is the P1 value, 750.5 into V1 is 0.216 gas consumption, 0.216, this is the gas consumption, and the gas temperature, that is 290. Now P2 value is 760, we have to find out the V2, and T2 value is 273. Okay, so from this relation V2 becomes 0.201 meter cube. This is V2. Okay, so now the gas used per stroke, gas used per stroke, that is 0.201 divided by the speed n by k. This is the 4-stroke engine, so k is half, so n by k, that means 240 by 2. Okay, so that becomes 0.001675 meter cube. This is the gas used per stroke. So now we are going to find out the volume of air at NTP. So volume occupied by air at NTP. the relation is PV equals to MRT. So V equals to MRT by P. So M is the air consumption, so that is 2.84 into R is 287 into temperature at NTP is 273 and the pressure at NTP is 1.01, that is the atmospheric pressure, into 10 to the power 5. So that is the value is 2.196 meter cube per minute, that is V. Okay, so this is the volume occupied by air at NTP. Now air used per stroke. Air used per stroke. So that is again 2.196 divided by 240 by 2, that means 0.0183 meter cube, 0.0183 meter cube at NTP. So mixture of gas and air used per stroke, that is mixture of gas and air used per stroke, that is 0.001675 plus 0.0183, that is 0.0199 meter cube. Okay, so now the volumetric efficiency. The formula of the volumetric efficiency is the actual volume of mixture drawn per stroke actual volume at NTP divided by the swept volume. Actual volume of the mixture drawn per stroke, actual volume of mixture drawn per stroke at NTP divided by the swept volume. So that is equals to 0.0199 divided by pi by 4 d square 0.25 square into L 0.75. So that becomes 0.853, or we can say 85.3%. This is the volumetric efficiency. Thank you.